Hello, this is Jeffrey Frankel with Solutions in Chemistry. Today I'm going to talk about a new topic in the new syllabus of IB Chemistry Paper 1. This is atom economy, and you can do these questions in less than 30 seconds. Essentially, when you're looking for a good description of atom economy, you're looking for the phrase useful or desired product, or words that mean the same. And if you look through these, the only one that really has that possibility is this one. B, a measure of the amount of starting materials that become useful products. And that is a good description of atom economy. It could say desired products become desired products, or sometimes I've seen both words used, useful desired products. So useful and desired are the words that you need to see in the definition. Let's look at some of the others. A stage in economic history in which atoms are sold in supermarkets. A load of rubbish. A measure of the amount of products that are used in atomic reactors. Of course, wrong. Absolutely wrong. Total mass of all products divided by total mass of all starting materials. Well, that's 1, isn't it? And expressed as a percentage, that's 100%, so that's wrong. The only one that fits is B. And remember, the word useful or desired, that is there. And it's a measure of the amount of the starting materials that become these useful or desired products. In this one, you have to be a little bit more specific, because they're asking for the definition. And again, you're looking for words useful or desired. And now C has total mass desired, and D has total mass desired. So let's check them out. Total mass of desired products divided by the total mass of all products and starting materials. Oh, products and starting materials? No, I don't think that's right. Total mass of desired products divided by total mass of all products and expressed as a percent. Yes, that's right. Now, the thing about this that you have to be careful is that it is the total mass of desired products divided by the total mass of all products, or it's the total mass of desired products divided by the total mass of all reactants or all starting materials. It's not both. So that's why that one's out. That's got both in. Total mass of products divided by total mass of starting materials and expressed as a percentage. No, it's nothing to do with the total mass of products. Total mass of products? No, it's nothing to do with the total mass of products. The correct definition is the total mass of desired products or useful products divided by the total mass of all products and expressed as a percentage. This is another one where you're looking for the one that is not correct. So let's see. That's possibly correct, possibly correct. This is not correct. The mass of most profitable product over total mass of product? No, that is definitely not correct. Total formula mass of useful products? Yes, that's probably correct. Without even investigating this one, and this one too closely, you can immediately see this one is wrong, because atom economy is not about profitability. And I think that can be done in 10 seconds or so. When looking at these kind of questions where they give you the various calculations and you have to choose which is the correct calculation, I choose something simple which it's got to have. And in this case it's got to have iron on the top. It's going to have 2 times 56 on the top. This one has 2 times 56 on the top. This one has 2 times 56 on the top. This one only has 56 on top. So that's not right. And that's not right. So let's look at this. This one I think doesn't look right because there's just not enough material in the bottom. There's only, as far as I can see, there's only iron oxide. There's no carbon dioxide. So that brings us back to this one. This one has iron oxide and carbon monoxide there. So A is the answer. Just to confirm, it could have had the corresponding numbers for 2 times iron plus 3 times carbon dioxide at the bottom. Just to summarize, I look for something that it must have, and it must have, in this case, 2 times the atomic mass of iron on the top. Must have. that eliminates two of them, that one and that one. And then that leaves you with the two, and you just then confirm the other piece of data. So this is another question about how much do you understand about atom economy. They tell you that the atom economy of this reaction based on iron is 52.3%, and which of the following statements is true? It's got nothing to do with the yield of formation. No, aluminium oxide does not have a valuable use. That's why the atom economy is based purely on the iron, not on the aluminium. If a use can be found for all of the aluminium oxide, then the atom economy of the reaction will increase to 100%. That looks a good one. That looks a good one. Just check that the others is not correct. Manufacturing profit? No, that's definitely got nothing to do with manufacturing profit. So C is the answer. If a use can be found for all of the aluminium oxide, that's that, then the atom economy of the reaction will increase to 100%. So let me just explain that. The atom economy of this reaction based on iron being the valuable product, or the useful product, or the desired product, is 52.3%. If both iron and aluminium oxide are valuable, useful, or desired, then the atom economy would be 100%. And that's why this one is the answer. And the others are totally wrong. This is again a question that could be done certainly in 10 or 15 seconds. An important difference between a yield and an atom economy is that a yield needs experimental data, whereas an atom economy is determined solely from the theoretical equation. Let's look at the yield. The yield equals the actual or the experimental, whichever way you want to call it, experimental mass of a particular product divided by the theoretical. And then you multiply them all by 100 to get a percentage. Whereas the atom economy, AE, equals the mass, and this is the theoretical mass as given by the equation, divided by, so it's the mass of, in this case, the useful product, which is R, in the same way that that was the mass of useful product, R. So that's the mass of R divided by the total mass. So that's the total mass. And it's important to remember that the total mass could be the sum of both of those, or it could be the sum of both of those, because they're equal. And it's from the theoretical equation these two figures come from. So let's look at the yield. We're looking at a yield of 100 grams of P reacts with 100 grams of Q to give 50 grams of R. So the theoretical in this case is 100 plus 100 would give 75 of R. So the yield equals, that's 75 on the ground, and there it's 50. So that equals 66.67% or thereabouts. That makes it look as though it's either this one or that one. So let's look at the atom economy for R. The atom economy for R is the theoretical value that you get for R, which is 75, divided by the total value you get on this side or that side, which is 200, which equals 37.5, and then they're expressed as a percentage. So that means the answer is D. The important point is a yield determines the experimental yield compared to the theoretical yield. Atom economy determines the theoretical yield of the material concerned in comparison to the total amount that is used in the experiment, whether it's determined from this side or determined from that side. If you found this YouTube video helpful, please subscribe to my channel Solutions in Chemistry and look at my other videos. Thank you.